Right, today we are here to learn histology of the connective tissue. But before we really go into detail of histology of connective tissue, we'll put the whole connective tissue in proper perspective in relation to the all other tissues in the body. So what is connective tissue? Where it is present in the body? What are its components? What are its functions? And of course, what are its dysfunctions? Right? So let's start with the very, very basic, and then we'll go to the connective tissue. You know that the basic fundamental block of the life is cell, isn't it? So let's start with cell, that this is a cell. Is that right? Now, actually cells are arranged together to make tissues. Now, what is tissue? First of all, we should define it. What is the difference in cell and tissue? Yes, please.
Tissue is composed of many cells.
Very good. Tissue is composed of many cells which are put together for some specific functions. Is that right? Tissues are made of group of cells which are put together, right? And structurally and functionally, they are having some specific features, right? So it means that tissues are group of cells. What are these? These are group of cells. So many cells group together and make the tissues, and different tissues are having different functions, right? And then, what are the basic tissues? What are the basic tissues which make your body? Yes, please. What are 4 basic tissues which make a full human being, so beautiful human being? Yes. What are 4 basic tissues? Anyone?
Muscle.
Okay, muscle. Muscle is one tissue, yes. You have to tell me 4 basic tissue which make all the human being.
Epithelium being one.
Epithelium, very good. Epithelial tissue. Epithelial tissue, yes. Then there is, you can say, muscle tissue. Right, and then there is nerve tissue. Nervous or nerve tissue. And another tissue which connect all of them, supports all of them structurally and functionally. Again, listen. Body is basically having 4 types of tissue. Is that right? What are tissues? Tissues are made of cells and they are having specific structural and functional characteristics. Right? Primarily, human tissues are divided into 4 categories. One is epithelial tissue. Is that right? You know the features of epithelial tissues mean many cells put together in close apposition. If there are many cells which are in close apposition and there is very little intercellular material. For example, this one cell, this is another cell. There is very little material in between the cells. If many cells are put together in close apposition, is that right? And with, this is basal lamina, other side is free. One side is free. Then this type of tissue is called epithelium. Is that right? So all our body having all those tissues in which cells are very closely packed. They are making the sheets. Is that right? Those sheets are sheets of cells in which there is very little intercellular material. Very little material in between the cells. And these sheets of cell are free on one side. These are called epithelium. They are called epithelium. Basically, epithelium has 3 things. Yes. It covers the external surface of the body, skin. It covers internal lining of the body, like lining of respiratory system, internal lining of urogenital system, internal lining of gastrointestinal system. Is that right? So all the respiratory system from nose down up to what? Lungs. It is lined by epithelium. Talk about the gastrointestinal system. It is lined throughout by epithelium. Urogenital system, I don't want to point out. Urogenital system, that also is lined by epithelium. These are internal linings. So one tissue I'm talking about, epithelial tissue, is made of many cells which are in close apposition. They are making sheets, and these sheets and layers are free on one side, and these cells, layers or sheets or epithelial tissue lines external surface of the body and lines internal surfaces of the body, as well as they make glands. As well as they make glands. There are three things. They make the basic linings in the body. Linings may be external surface lining, yes, internal surface lining, plus epithelial cells also line the body cavities. Body cavities. There's abdominal cavity. It is all lined by epithelial tissue. And then some epithelial cells, right, they make a specialized structures called glands. Right? So this is one tissue, epithelial tissue. Other tissue in the body which is very important is, and very basic tissue is muscle tissue. Right? All your skeletal muscles and smooth muscles and cardiac muscles, right? They are made of muscle tissue. Now in the muscle tissue, very special thing about muscle tissue is, the most important unique feature of the muscle tissue is it has contractile proteins. Muscle tissue is made of muscle cells. The very special thing about the muscle cell is they are having the proteins which help the cell to contract, help the cell to shorten. Is that right? Like actin and myosin and tropomyosin, we will discuss in detail later. So, cells make tissues, and 4 basic tissues make your body, right? First basic tissue I told you, epithelial tissue, where cells are in close opposition and making the linings and glands outside the body and inside the body. Muscle tissue. Muscle tissues are consisting of muscle cells. What is very special thing about muscle cells? They are having contractile proteins, so they can contract. Heart can contract and move the blood. GIT has smooth muscle which contract and move the content of the GIT. And of course your limbs have the skeletal muscles which move you. Is that right? Then nerve tissue. What is the very special thing about nerve tissue? Nerve tissue consists of very specialized cells which can receive information, integrate information, and transmit information. Nerve tissue consists of very special type of cells called neuron. I make a very simple neuron. Neuron can receive information through electrical and electrochemical impulses. Neurons can receive information, integrate information, and transmit information. A high-speed information network in your body. Nerve tissue. Is that right? And all these tissues, epithelial tissue, muscle tissue, nerve tissue, all of them are connected and supported structurally and functionally by connective tissue. Connective tissue. This is what we are going to study in detail. So what is connective tissue? Connective tissue is present all over the body. It is present all over the body. It is present in central nervous system, it is present in your heart, it is present in your skin. You name any tissue, it has connective tissue. You name any tissue, it has connective tissue. What is connective tissue? Connective tissue is a special type of tissue which connects all other tissues and supports the other tissue for structurally supporting the other tissues and functionally supporting the other tissues. Let me tell you what is really meant by this. Let's suppose here you have epithelium of the skin. This is your skin. There are, of course, there are cells, basal cells here and multi-layers. What is the type of epithelium in the skin? What is the type of epithelium? Stratified squamous epithelium. Now, this is skin. It has glands, of course, like sweat glands and sebaceous glands. You know that, right? There are glands sweating. Now, look, skin need to be supported. It should have connective tissue, isn't it? So connective tissue is under it, and let's suppose this is connective tissue of the skin, this blue. Now, what is the function of this connective tissue? It should structurally support the epithelium of the skin, and it should functionally support the epithelium of the skin. How? Structurally, how it is supporting? For example, this underlying connective tissue of the skin, which is called dermis. What is it called? Dermis. And this epithelium is called epidermis. Now, skin consists of both things, right? This is the epithelium of the skin. This is the connective tissue of the skin. What I'm saying, connective tissue has one function, that connect the different element. For example, under it there is a muscle, or under it there is a bone. So skin is connected through the connective tissue with other tissue. Epithelium is connected through the connective tissue with underlying structures, number one. Number two, it's structurally supporting it. Number three is functionally supporting also. How it is functionally supporting? Let's suppose here there is a blood vessel. Now, any nutrition has to come through the connective tissue up to the skin epithelium. If glucose has to go, that has to pass through the connective tissue, isn't it? If oxygen has to pass through the connective tissue, the waste product have to go back through the connective tissue to the vascular system. Are you understanding? So what it is doing is functionally supporting it. So connective tissue structurally support the tissues, functionally support the tissues. It is present throughout the body and even have one very important function. Connective tissue has many types of cells, and it has very important cells which play a role in defense, body defenses. When bacteria come here, connective tissue may have some cells which belong to the immune system. Again, for example, if bacteria or pathogen come in, they're trying to destroy the skin. In this layer of the skin, there will be cells which act as defensive mechanisms. There may be macrophages which eat the bacteria. There may be mast cells which will produce inflammatory response to injury, right? So it means another function of the connective tissue is building the defense mechanisms, right? So how many functions of connective tissue we know? It structurally supports the tissues, it functionally supports the tissues, and of course it is having many cells and components which play a role in defense against the microbes and other pathogens, right? And then if skin is injured, let's suppose you injure the skin here, right? There's some injury here. Then there are connective tissue cells here. Cells from the connective tissue will multiply and fill the gap and make a scar. It means connective tissue also plays a role in repair of the injured tissue. Connective tissue plays a role in repair of the injured tissue. So how many things we learned about connective tissue? Connective tissue is responsible to provide structural strength to the tissues. It is responsible to provide functional support to the tissue, right? And connective tissue is responsible to provide the defense mechanisms, right? It has many cells, and of course, connective tissue has cells which help in the repair of the tissue. Is that clear? Now, we will talk about other details later, but we have to see what connective tissue is. What it consists of, what type of components. Now we have to think. I just said the connective tissue is there, right? But what it is? What is its microstructure? What are its micro components? Connective tissue is made of what? Who will tell me? It's made of what? First of all, tell me cells at least. Every tissue has cells, right? Right? It's a very simple thing. Every tissue has cells, so connective tissue must have cells. So number one, there are cells. What else? Fibers, that's good. What else? Ground substance. I think it's something like a jungle. Yeah. You know, if you go to a jungle, you will have some ground with a lot of trees and a lot of monkeys around. It's a monkey forest. Connective tissue is like monkey forest. We can make the basic components of the connective tissue that these are three basic components here, first of all. And this is the ground, and on the ground there must be what? In the jungle, there must be trees, isn't it? Some trees are really thick with big stems. Non-branching trees. Then there are thin trees, and then there are branching. So this is a jungle of connective tissue. It is having a ground, and of course you should not forget what are there. Yeah, he knows them. Is that right? So what are these monkeys? What are these monkeys? Right? What are these monkeys? I will keep on drawing the monkeys until you don't tell me. What are these monkeys? Yeah, cells. That's good. So we have to study this monkey business, monkey jungle. What is connective tissue? It's a jungle which is made of some ground substance with some fibers and with some cells. Is that right? We'll study every component one by one. We'll study that cells in detail, from where these monkeys come first of all. Then we have to talk about from where these fibers come and from where this ground substance come. You must be knowing that this ground substance has three basic components. Number one, glycosaminoglycans. This is a special component. I will teach you in detail later. Right? These are special type of macromolecules. These are called glycosaminoglycans. Then there are proteoglycans. I will go into detail of all of them, don't worry. The glycosaminoglycans, the proteoglycans, and they are glycoproteins. So these are the ground substance. You take any tissue in the body, right? It will have ground substance which will be made of glycosaminoglycans, proteoglycans, and glycoproteins. Number one. Number two, there are, of course, this is jungle, there must be trees. What are these? These are connective tissue fibers. What are these? Connective tissue fibers. These are thick fiber. These are very thick fibers. And these thick fibers and unbranched, right? What are these fibers called? Collagen. Is that right? They are thick and unbranched. And there are thin fibers. Thin fibers. Is that right? And these thin fibers are really thin. They are about 0.3 to 0.5 micron. And collagen fibers, these thick collagen fibers are 10 to 300 micron. Okay. Don't remember even these sizes. No one is going to ask. Just remember they are thick and there are thin fibers. Both are unbranched. Thick unbranched are collagen. Thin unbranched are, yes please? Yes? Reticular fibers. That's great. These are reticular fibers. Excellent. And these branching fibers. What are these? These branching fibers which are present in connective tissue. Elastic fibers. That's right. Elastin or elastic fibers. Elastic fibers. So now, what we have learned up to now, that connective tissue has three basic components, right? There is ground substance and there are fibers. Is that right? And then there are monkeys. What are these monkeys? Cells of the connective tissue. So write it down that connective tissue is equal to cells of the connective tissue plus these two things. All other things other than the monkey. All other things other than the monkeys are called, they are outside the cells. These fibers are outside the cells and these ground substance material is outside the cells because cells are monkeys. So all material which is outside the cell is also called extracellular, yes, matrix. And of course extracellular matrix has two components. You already know there are ground, yes, ground substance and fibers. So what is connective tissue? Connective tissue is a tissue that structurally and functionally supports other tissues. Is that right? It consists of connective tissue cells and extracellular matrix. The very special feature of connective tissue is that there are less cells and in between the cells there are a lot of extracellular material. The extracellular material or material in between the cell or material outside the cells is also called extracellular matrix. An extracellular matrix basically consists of fibers, right? And in between the fibers, this filling material is ground substance. And then it's so easy to understand that fibers are how many types? There are collagen fiber, then there are, yes, reticular fibers, and there are elastic fibers. Remember one thing, the reticular fibers are very special type of collagen fiber. Should be there. It means one of you is not sleeping. That's very good. So one of you pointed out fibers should be on the fiber side. And what about others? Collagen, yes. Reticular, collagen are thick, unbranched. Reticular are thin, unbranched. Reticular fibers, and elastic fibers, which are thin with branching. Is that right? These are the fibers. And in between the fiber, there is proteinaceous material and proteins and carbohydrate made material that is called ground substance. What are these three components? Yes. Glycosaminoglycans, yes. Proteoglycans and glycoproteins, right? These things we'll study later, right? Fibers and ground substance. Today we'll concentrate mainly on the cells of the connective tissue. One thing, from where, who is making all these fibers? From where these fibers are coming? Yes. Life started with a zygote, isn't it? Your life started as a zygote, and then you become a full human being. Who put all these fibers there? From where these fibers come? Anyone? These monkeys produce these fibers. This is a jungle produced by the monkeys. You know, one of very important monkeys, fibroblast. Fibroblast, a very special cell. A very tough monkey in the jungle. I should say it's the father of the jungle. Because fibroblasts produce elastic fiber. Fibroblasts produce collagen fiber. Fibroblasts produce reticular fibers. The jungle is produced by which cells? Fibroblast. Is that right? What fibroblasts are doing? Fibroblasts take up the amino acids and they have secret code how to bind the amino acids and make fibers. And they spill out fibers around them. And in this way, monkeys are producing the jungles. Even ground substance is also produced by fibroblasts and by some other connective tissue cells. So originally what was there? Cells. Originally what was there in connective tissue? Cells. And then cells produce the ground substance and cells produce the fibers. Am I clear? Right? Now this was the very basic. Let's start about the cells, from where these connective tissue cells come in this jungle. Connective tissue cells are so many types. We'll go into detail. But first of all, from where these connective tissue cells come. Let's start from very simple concept. The life starts from zygote, isn't it? Here is ovum and here is a successful sperm going into, I will make a very simple diagram. What is this? Male pronucleus and female pronucleus. And what is this? Zygote. 2-cell stage. You know it, na? 2-cell stage, yes. Divide into 4-cell stage. Yes, you tell me the next stage. In the end, we'll make connective tissue cells. Right? So there was ovum, of course, in the female, and sperm coming from the male, uniting together in, where they unite together? In the female, within the fallopian tube, in case of natural fertilization, right? Zygote, divide into 2-cell, 4-cell stage, then what is this? Morula stage. You have not done embryo. Then from morula stage you go to, yes, blastocyst stage. You are understanding? There was just one cell, it contained 2 cell, 2 into 4 cell, 4 cell into 16 cell. Is it difficult to understand? Then this mass of cell, some water goes in, and once mass of the cell is pushed on the side, this is morula. In the morula, water goes in. And then what happens? This is water-filled area, and remaining cells are pushed on that side. These cells are going to make the baby. These cells are going to make the baby. Cells will talk to each other. You make this tissue, I'll make that tissue. Right? They start talking so early. So this is blastocyst. Then what happens to blastocyst? Yes, please. It makes, two cell layer. This is one layer of cell, and this is second layer of cell. This is called bilaminar disc. Bilaminar disc. You are understanding? We are going to make a baby very soon. Right? So bilaminar disc is made. Bilaminar disc is made after how many weeks of fertilization? Bilaminar disc is made, for example, let's suppose you are really married and you have a good female and you fertilize her. She gets fertilized today. And so, then I should ask her. So when it will take how much time to make a bilaminar disc for you? It's so easy. Bilaminar disc. Bi mean 2. Trilaminar disc 3 weeks. After the fertilization, within 2 weeks, bilaminar disc stage will come. Your baby will be just 2 layers of cells. And then in 3 weeks it will be 3 layers of cells. Right? So don't be sad. It will become a proper baby eventually. Now, this is bilaminar disc. By the second week of fertilization, after the fertilization, and then it will convert into trilaminar disc. I will make trilaminar. This is the upper layer, which is called epiderm. Then there is inner layer, which is called lowermost layer is endoderm, and in between the uppermost and lowermost layer, there is another layer of cells. You will discuss in detail in embryo how this layer is made. This cell layer is called mesoderm. You know, most of your connective tissue will be derived from mesoderm. Is that right? From where, you know, there are many structures which are made of ectoderm. For example, ectoderm will make your central nervous system. Ectoderm will make the layer of the skin. Is that right? Endoderm will make the GIT lining. And the cells present in mesoderm, they will eventually convert into mesenchyme. And many cells of mesenchyme will convert into connective tissue cells. And then connective tissue cells will produce connective tissue fibers and ground substance. Am I clear? It's so simple.
Yes.
Isn't it? Thank God it happens automatically. Yeah, it will be difficult if you have to do it yourself. So what happens is mesoderm, and this mesodermal cells, many of the mesoderms make many things, right? Some of the mesodermal cells, they become very loose, and these loose cells, right, they start producing some extracellular material. These are the beginning of the monkey business, right? Now, these mesodermal cells initially, which become very loose and they start produce some material, right, some proteinaceous material around them, whole this mass is said to be mesenchyme. What is it? Mesenchyme. So what is mesenchyme? It is made in early embryo, very early stage of development of the embryo, right? This from the yes. How we make from the mesoderm mesenchyme? Okay, you want to really know detail? Let me tell you. This structure, for example, if you are standing here and you look at it, how is the structure developing? I will just remove this. This is ectoderm layer. Is that right? And here it is. Initially, this is the lower. Start from the bilaminar disc. This is upper layer and this is lower layer. Upper layer is epiblast, lower layer is hypoblast initially. Is that right? Now what really happens that at this point, here is the whole baby thing. Right now, you are standing here and looking what's going on. Right? Actually, at this point, these two discs, upper disc which is epiblast layer and hypoblast layer. You press them together, and here they are sticky to each other. Again, listen, it's just like this, that you have two layers, right? This is upper layer and this is lower layer. And at this point, I press them together. Why I'm pressing them together? Because here two layers should not separate. You know why? This point where I'm pressing together, this is going to be mouth. So this is the interior upper part of the body going to develop, and here lower part of the body going to develop. Is that right? Now, at this point, some cells in the middle, some cells die. Some cells die. When these cells die, like this, in this area, some cells undergo death process. When they die, a long line is made, right? And this line is defect. Defect means that this was upper layer, right? From here, some cells die. When these cells die, it open up like this. Am I clear? Right? Here is baby upper part. This is going to be baby lower part. We call it rostral part and caudal part, or superior part and eventually inferior part, mouth end and hypothetically tail end. Now, here some cells die, gap is made, and this is the lower layer. Then what happens? Cells at this point, they will start multiplying, and they'll move like this, down. Cells from this cell multiply and go down. And these cells which are going down, they are going to make mesoderm. Because these cells which are going down like this, they will come in between the uppermost layer and the lowermost layer and create the middle layer. They will create a middle layer. And this bilaminar disc will convert into trilaminar disc. Am I clear? It's so simple. That you started with one zygote, 2 cell stage, 4 cell stage, 8 cell stage, morula. Water goes into morula, some cells pushed on one side, and remaining area of the morula full of water. Now it is called blastocyst. Then cells, these cells which are going to make baby, they are compressed into a disc. That becomes bilaminar disc. Has upper layer and lower layer. Upper layer is epiblast, lower layer is hypoblast. And then at one point they are compressed together. It's so early it is decided that this is going to be head and neck area and mouth, where they become sticky with each other. Then here they are sticky. This is called procaudal plate. What is it called? Have you heard of it? Procaudal plate. Then here some cell die in the upper plate, and a longitudinal long gap is fissure is produced in upper plate. From here the cell multiply from the side and go down. From here they go down. From here they go down, and they create another layer between uppermost and lowermost layer. And this middle layer is called mesoderm. Now eventually baby will consist of, rather I must say not baby, very early stage of development. So this will consist of, we should not forget. What is this? Uppermost layer now should be called, now what it should be called? Ectoderm. Ectoderm. Then through this we have made a middle layer. What should be it called? Yes, please. It's mesoderm. Right? Under it there is one more layer of cells, and what is that? Endoderm. Do you want to make a baby out of these 3 layers? It's very easy. But don't forget, we are studying connective tissue. Most of the connective tissue will be derived from mesoderm. Now you see, you have, okay, why don't you show me some papers? Can I have it? Okay. This is our, what is this? Uppermost, ectoderm. And this is lowermost, mesoderm. And in between that we have filled the mesoderm. And lowermost is endoderm. So ectoderm, in the middle there is mesoderm, and lowermost is endoderm. I want to have mesoderm from somewhere. Okay, we have a mesoderm here. Okay, this below. Now you understand. Ectoderm, this is mesoderm, and this is endoderm. Now what you do? It's so easy. You just fold it like this. This becomes whole skin. Right? This mesoderm is in the center. It will make muscles and bones and other things. And this is the GIT lining. Is that right? Is it difficult? Raheel, you understand it? So then from the top you bend it. And this point where it was sticky, when you bend it, it comes in the anterior mouth. Then you hold from this and pull it out on this side and this side. Arms. Are you understanding it? Is that right? In the arm, ectoderm will come as skin. In between, mesoderm will come, which will make a lot of muscles and bones of the arm, of course. And you put from this side also. Legs. Is that right? Is it difficult? No, it's so easy, isn't it? Clear? And of course, in the ectoderm, some cells will multiply here and they will make your central nervous system. We'll talk about these things in embryology. You have your tissue back. Now, after having this very basic concept, I was saying these mesodermal cells, which are between the ectoderm and endoderm, they will provide connective tissue just under the skin. Of course, they will also provide connective tissue around the GIT and inner organs. Is that right? Now, actually the cells which are in the mesoderm, listen now, the cells which are making the mesoderm, they become very loose and they produce a lot of proteins. If I'm a cell and start produce a lot of proteins, I will be having a lot of proteins and carbohydrates around me, proteins and glycoproteins. If she is another cell, she will also have a lot of proteins produced. Now, all these cells become loose with each other. You come here, I will explain. You also come here. Hurry up. Let's suppose we are 3 cells of mesoderm. We are 3 cells of mesoderm. Then all of us start producing and releasing what? Proteins and?
Camera shots.
Proteins and different type of fibers and proteins and glycoproteins and carbohydrate. And then, of course, because we are releasing the material, all of us, so we'll start separating from each other. And what is this in between? Ground substance and fibers are being generated. Don't tell we are monkeys. Right? Eventually we'll convert into special monkeys of connective tissue. Right? Now, in the beginning, when they are separating from each other, tissue is very loose. It is still in the embryo. But with our fingertips, we are connecting with each other. Like this. So, what is this? Cells are going away, but through fingertips, they are connected. What are these fingertips? Cellular extensions. These are cellular extensions. And through these extensions, there are electrical windows between the membrane. What we are doing? We are electrically communicating to each other. You are going to be connective tissue brain, and I'm going to be connective tissue heart, and you can be connective tissue in the foot. Is that right? So, what really happens? Even cells talk to each other. And these loose cells, away from each other, with a lot of ground substance and little fibers in between, all this mass is called mesenchyme. What is it called? Mesenchyme. Have a seat, mesenchyme, please. So, all these cells are mesenchyme, right? Now, we have made the mesenchyme in the embryo, right? Now, this mesenchyme will make many things, including the connective tissue. So, we'll talk about how eventually connective tissue cells are made. This is mesenchyme. I take this mesenchyme on this side. Okay. Rather, I'll make mesenchyme in a very... This is mesenchymal tissue. Primitive. Yes, what is it? Primitive. Mesenchymal cells. Let's suppose this is some primitive mesenchymal cell. Is that right? This is the first monkey produced. And what is this monkey? First, primitive mesenchymal cells. Is that right? Now, there are, as embryo is growing, new tissues and organs are made. Is that right? The organs, important organs in our discussion is, first of all, yolk sac. You know yolk sac is made during the development of the embryo? Or you don't know it? Okay, this is the embryo developing. This pocket is called yolk sac. Actually, some of the primitive mesenchymal cells, this is a mesenchymal cell, some of these go to, they are present in where? Yolk sac. Some of these, what are these? mesenchymal cells, they are present in yolk sac. In the yolk cell, they start producing stem cells for hematopoiesis. They convert into stem cells for hematopoiesis. I will draw this cell here. What is this cell? Hematopoietic stem cell. Let me tell you what is hematopoiesis. Hematopoietic stem cell mean that this cell can multiply and give rise to blood cells. This cell can multiply and make RBCs, make WBCs and platelets. Is that right? So from where the cells are coming which make the blood cells? From the mesenchyme. So from the mesoderm. Is that right? So some of the mesenchymal cells, primitive mesenchymal cells, they are present in the yolk sac and they convert into specialized cells which are called hematopoietic stem cell. And you must know what is the meaning of stem cell. Meaning of the stem cell is that stem cell is a special type of cell. When it multiplies, it maintains its population. Let me tell you how. This is a difficult definition. Let's suppose this is one cell. This is cell A. It divides into cell B and C. And B divide into, for example, cell number 1, cell number 2, and C divide into cell number 3 and C cell number 4. Do you think cell A will be left there? Cell A divided into B and C, and B and C, B cell divided into cell number 1 and 2, C cell divided into 3 and 4. Do you think A will be still there? No. Now you imagine another cell. This is A cell, divide into B and C, but meanwhile when it divide, it make another A. And then they go into 1, 2, 3 and 4. So it keep on multiplying and giving the supply of cell number 1, keep on giving the supply of cell number 2, keep on giving the supply of cell number 3, keep on giving the supply of cell number 4, while maintaining its own population. Because whenever it divides, not only it gives differentiated product, but it makes its own copy as well. Such cell, if you put this cell into a petri dish and culture, it will keep on multiplying if you give proper stimulus. It will make a lot of different type of cells, but it will maintain its own population also. But if you put this cell into a culture dish and stimulate it, it will convert into B and C and then 1, 2, 3, 4, and in the end you won't have any A, B and C. So such cells, while they are multiplying, they give the product cell, but they lose their own existence. These are called progenitor cells. What are these called? Progenitor cells or precursor cell. And such cells, when they are multiplying, even though they are giving differentiated product, but they do maintain their own population. These cells are called stem cells. This is the concept of stem cell. Such cells in the body are called stem cells. What is the most beautiful point about stem cell is that when they multiply, not only they keep on giving the differentiated product, but they also maintain their own population. For example, Mr. Rahil is sitting here. He gives 100 babies somehow. And then he becomes old man and dies. Do you think he is stem cell? No. He is like a precursor cell or progenitor cell. But let's suppose there is another person here, right? And that person, whenever he gives 2 babies, he makes his own clone also. Do you get it? So he survives as well as makes a lot of babies. And always maintaining his youthful appearance as well, never getting old. What is that? Stem cell. Am I clear? So what I was trying to tell you, some of the mesenchymal cells, primitive mesenchymal cells remain in your body for all your life and keep on behaving like different types of stem cells. Is that right? Some of these stem cells go to the yolk sac and there, these are called hematopoietic stem cells which can give rise to blood cells, RBCs, WBCs and platelets while maintaining their own population. But you know, when baby is born, is there any yolk sac? No. This primitive yolk sac disappears. during the development of the baby, primitive yolk sac disappears, dissolves and disappears. It means these very valuable cells should rush from here to somewhere else, because this will eventually disappear from the baby. It will disintegrate in the development of the embryo. So even though these cells come into yolk sac, make the primitive hematopoietic stem cells, very soon these cells migrate to liver and spleen of the baby. These cells migrate to the newly developing, yes, liver and spleen of the baby. Then blood will be made where in the baby? By liver and spleen. You understand it? So what really happens in a newly developing embryo? First of all, blood cells are made in yolk sac. Later on, liver of the fetus and spleen of the fetus also act as organ which produce blood cells. Is that right? And then by the time baby is going to take birth, I'm not going to make a baby, right? So actually in the baby there is, in the last trimester, right, what happens? Most of these stem cells populate the spaces in the bone, newly forming bone. And when these cells go into spaces of the bone and they multiply there, that newly developed tissue is called bone marrow. What is that called? Bone marrow. So when baby is born, these RBCs, WBCs and platelet forming cells are present in bone marrow. You are understanding? They are present in bone marrow. Right? So it means that bone marrow house, when you are born, most of your RBCs and WBCs and platelets are being made in bone marrow. Is that right? Am I clear? Now, you are adult people, and still in your body, every day new RBCs, WBCs and platelets are made, and old cells keep on dying. They are made where now? In the bone marrow. So we can say history of from now, it means bone marrow has special type of stem cell which are called hematopoietic stem cells, which are responsible to make RBCs, WBCs and platelets. Am I clear? No problem up to this? Now, so in a nutshell, we can say that these mesenchymal cells, which are mostly derived from mesoderm. There's a little exception here. Let me make that to your notice. Mesenchyme mostly is coming from mesoderm. But in the developing baby, near the head region, some ectoderm also convert into special type of neural crest cells. They also convert into mesenchyme. So it means most of the mesenchyme is coming from mesoderm, and a little mesenchyme is made from the ectoderm in the head region. Is that right? That is called ectomesenchyme. But if you find it difficult to remember, just remember that in the baby, most of the mesenchyme is made from mesoderm. Is that right? A little from ectoderm. And this mesenchyme generates many types of cells. One of the cells is hematopoietic stem cells, which initially proliferate in yolk sac, then they proliferate in liver and spleen, and eventually those stem cells shift to bone marrow, and all your life they keep on producing RBCs, WBCs and platelets. Am I clear? You may be thinking, why I'm talking about the blood? You know, blood is also connective tissue. Is that right? Now, so in our discussion, while jungle will be there, we can say eventually yolk sac, liver, yes, spleen, and then eventually which tissue is going to take control of? Yeah, what is this? Bone marrow house. Bone marrow house after the birth. And it is well populated by, what is this? Bone marrow, hematopoietic stem cells, and it came from mesoderm or mesenchyme. Claro? Now, here is suppose your circulation. What is this? Your circulatory system, blood vessels I'm showing. Is that right? And let's suppose here these are the other tissue layers. Let's suppose here was epithelium. We make the epithelium here. Epithelium of the skin. Is that right? Now, in between here, blood vessels, what is this area now? This is connective tissue. What is it? It is connective tissue. Now, how these connective tissue cells will be coming there? Many cells will come directly from here. Many cells will come directly from the mesenchyme, and many cells will come from the bone marrow to the blood to the connective tissue. So it means, what are the sources of cells in the connective tissue? In the connective tissue cells may be directly derived from primitive mesenchymal cells, or cells may be coming from bone marrow house. But actually, cells of the bone marrow house are also derivative from original mesenchymal pathway or mesodermal pathway. Is that right? Now, we'll come to what are these cells, different types of cells here. Yes, who will tell me? Connective tissue cells. First of all, some of them are permanently resident here. There are some cells, there are some monkeys, there are some cells which permanently live in your connective tissue. So they are called permanent resident cells. Is that right? And there are some monkeys which are not in the jungle. There are some monkeys, some connective tissue cells which are coming from bone marrow house, and they are wandering and come here. And they come here and maybe go back to the blood and may go to some other area. So there are two types of monkeys in connective tissue. They are permanent resident monkeys and transient monkeys. We also call them wandering monkeys. What does it mean? I have a skin here. Under the skin there is connective tissue. In this connective tissue there must be connective tissue cells. Some cells are permanently living under the skin connective tissue, and other cells may be coming from the blood into skin connective tissue, and they may go to some other area in the body. So there are two types of connective tissue cells. Yes. Number one, permanent resident connective tissue cells, which are coming directly from the mesenchymal cells. And there are other cells which are coming from the bone hematopoiesis, right? Either hematopoiesis occurs in yolk sac or liver and spleen or in the bone marrow. After the hematopoiesis, they come into blood, and from the blood they may come to, from circulation they may come into connective tissue. These are called which type of cells? Wandering connective tissue cells, or other name for them is transient connective tissue cells. Is that clear? Now, let's see which are the permanent cells and which are the transient cells, and then we'll go into detail of each cell. Permanent cell, the most important cell which you should know is, what is this cell? I will tell you the features of this monkey. This is a cell which is responsible to produce collagen. It is responsible to produce elastic fibers. It is responsible to produce reticular fibers. It is responsible to produce many glycosaminoglycans. I don't know who put this difficult name. Right? Or proteoglycans or glycoproteins. So this monkey is the really jungle producing monkey. This monkey is a special type of cell derived from primitive mesenchymal cell. What is the name of this very special cell? Fibroblast. So what is this? Fibroblast. No difficulty? Okay. Then from this primitive mesenchymal cells, right, another type of cell is derived, and that type of cell is very, it has made too much, jungle around it. And it is itself compressed in between its product. You have to tell me the cell. Listen carefully, I am putting a question. Primitive mesenchymal cell convert into a special type of connective tissue cell. This cell produces a lot of collagen. It produces so much collagen that it is trapped and compressed between the collagen bundles. And you know then what happens? It's all around having collagen. You should not be producing so much things. And then lot of calcium deposits into this. What is this? It is your bone being made. Right? And what is this? Osteo? When it was fully active, it is called osteoblast. And when it is surrounded by all these things and sleeps and squeezed in between, it is called osteocyte. What is the difference in cyte and blast? What is the difference in cyte and blast? Yes, please.
Blast is producing and the site stops.
It's simply when cells are multiplying and very active, they are blast. And when cells are inactive and not multiplying, they are cyte. That is why you have to remember that fibroblast means a cell which is very active, and when it becomes quiescent, it becomes off, it is not working well, it is sleeping, it's under activity, not multiplying, it is fibrocyte. In the same way, another monkey derived from this primitive monkey. This primitive monkey is primitive mesenchymal cell. Don't tell others that Dr. Najib only teaches monkeys. So primitive mesenchymal cell go and make a special type of cell, and this cell produces a lot of collagen, and then collagen gets calcified, and this becomes a piece of bone. And when all collagen around it, right, and surrounds it, and then it becomes inactive. So osteoblast convert into osteocyte. Is that right? Then there is another monkey. In jungle there are so many different type of monkeys. It's a bit stylish, right? And it does produce some collagen, but it also produces a special type of connective tissue which is called hyaluronic acid. What is it called? Hyaluronic acid. And it fills a lot of tissue around it with hyaluronic acid.
Can you write that word?
Hyaluronic acid. Hyaluronic acid. Don't trust my spellings. I don't know why. I always like to write like this. Right? Hyaluronic acid. Now, this cell produces a lot of hyaluronic acid and produces collagen, and it does not get calcified if it is healthy. And this tissue is called, this is a special feature. This is also a connective tissue. This is a connective tissue cell, and it's a connective tissue. What is this? Yes. It is cartilage, and it should be called chondroblast. When it is active, and when it has done a lot of activity, and it becomes inactive, it is called chondrocyte. Is that right? So what is it called? Chondrocyte. Is that right? No problem up to this? Then we can come to another monkey. It should remind some chief executive of a company. Look at this monkey. No, he's a smart man. Yeah, what is this monkey? It is not secreting the things out. It's a funny monkey. It is accumulating the things in. Yeah, tell me which is the connective tissue cell which accumulates the fat in. It takes the fatty acids and glycerols. These are fatty acids, 3 fatty acids. It takes 3 fatty acids and bind them with 1 glycerol, and this becomes triglyceride. So it is triglyceride accumulating cell. It accumulates the fat. So don't call it fat cell. It is in medical literature it is called adipocyte. Adipocyte. What was this? Chondroblast and eventually chondrocyte. This was osteoblast and eventually osteocyte. Is it difficult? Then there is, of course, what type of cells are present within this capillary. This is a capillary. What are these cells? What is this cell? What are these cells lining the capillaries? Capillaries are lined by a special type of cells which are called endothelial cells. So these are endothelial cells. They are lining all the cardiovascular system. These endothelial cells are also derived from this primitive monkey.